Hello everyone, good afternoon. Dear authors and invited guests, welcome to the technical session 5A. My name is Siddhi Audi and I'll be your session moderator for this session. On the behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you all to the 10th International Conference on ICT for Sustainable Development, ICT4SD 2025. The 10th edition of the conference is being organized in a hybrid mode. The physical event is being held today in Goa, and the virtual event is being held via Zoom meeting from 17th to 19th July 2025. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we will be having total 10 presentations. Each presenter will be given a time span of 8 minutes for the presentation and 2 minutes for question and answers. I will be raising a gentle reminder from time to time. I request all the participants to please consider and respect the time constraint. Also, there is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or any technical issue, you can write it to me in the chat box. Now, just before we get started, I would like to introduce you all to today's session chair, Dr. Anuradha Yenkikar. Dr. Anuradha Yankikar is an associate professor at Vishwakarma Institute of Information Technology. She is currently working at the Department of CSE, Artificial Intelligence, VIIT. She has published more than 30 research articles in reputed journals with SCIE, Web of Science, Scopus Indexing. She has also published many book chapters and patents. Her research interests include data science, machine learning, artificial intelligence, deep learning, and parallel computing. Welcome, ma'am. Thank you for joining us today. Now,
Yes,
without any
thank you. Thanks, Siddhi, for the introduction.
uh, without any further ado, we will proceed to the first presenter. So, the very first participant is Gauri Bhagat from MIT Art, Design and Technology University, India. And the paper title is a novel multi-domain ECG feature analysis approach for precise arrhythmia diagnosis. Gauri, ma'am, please start with your presentation. I'll stop sharing my screen now.
Okay, thank you. Now I will share.
Hello, Gauri madam.
PPT is visible. You can start with your presentation.
You're on mute. Can you unmute yourself, please?
Hello. Gauri ma'am, you have muted yourself. Your voice is not audible.
Now it is.
Yes,
Yes,
yes.
now it's audible.
Good morning, good afternoon, everyone. My name is Gauri Bhagat. I am from MIT ADT University, Pune. I am here to present our work on a novel framework for arrhythmia detection using the electrocardiogram signals. In this study, we have explored the integrated and the adaptive approach using machine learning to significantly improve the accuracy and robustness of arrhythmia diagnostics, which is the pressing need in modern cardiology and telemedicine. Actually, we are working on the arrhythmia detection. What is the meaning of arrhythmia? Arrhythmia nothing but the irregular heartbeats. So, we are working on that. So, this is the outline of my presentation. The but first slide is a motivation. Now here, the cardiovascular disease, particularly arrhythmia, remains the major health concern globally. One of the biggest challenges in early diagnosis is the lands on the manual ECG interpretation, which is the prone to the human error. Existing automated methods often analyze only one domain, like timing or morphology, so missing out the complex pattern. So our motivation is to create the holistic machine learning enabled system that merge the feature from multiple domains to offer the accurate patient adapted diagnosis. The objective, the main goal of this research is to build the multi-domain ECG analysis system. We integrated the morphological feature like QRS shape, timing matrix like AR interval, and the spectrum features using wavelength transform. However, we have introduced the adaptive components to handle the patient's significant variation. Our final model combines our result from multiple classifier to improve the accuracy and reduce the false positive and negatives. Importantly, our system is to design to work on mobile and edge devices, making it highly scalable and healthcare friendly. Research gap. From the literature, we have noticed that time domain features are commonly used due to their simplicity, but they often fail to detect the complex arrhythmia. So frequency domain techniques are more informative but computationally expensive. So morphological method is rely on clean signals, which are rare in a real world scenario. So additionally, the most system use the static thresholds, which don't account for the patient to patient variables. So our work address these by creating the adaptive and unified and robust system. Framework overview. Now this slide summarize the framework. We begin collecting the ECG data from we have begin collecting the ECG uh, data from the standard database like MIT-BHI. The signal is clean and normalized. We then segment it using R peak detection and extract the variety of features. These features are passed through the multiple classifier SVM, random forest, and CNN. Finally, a decision support layer interpret the result, which confidence scoring. The modular design ensures this work can work in both the hospital and setting and the portal health monitors. Next, data acquisition and pre-processing. So we use the MIT BHI dataset as our primary input source, which is the widely accepted in arrhythmia research. So we apply the Butterworth filter to clean the data. Further, the signal dependent and media filtering to help the normalize the wavelength, eliminate the drift. For RPEG detection, we improve our classic pan-toponym algorithm by tuning for individual patient baseline. The multi-domain feature extraction. Uh, so this is the core of our system. We extracted the feature from three domains: the morphology, time, frequency. For example, we use the wavelength decomposition to capture the frequent trend. Simultaneously, we calculate the RRQR intervals and also extracted the properties of ECG wave. To address the individual variability, we apply the adaptive thresholds learned from cluster the patient's own data. This makes the model more balanced to abnormal cases. Classification model. So we use the three classifiers to compare the performance. SPM is a reliable baseline. Random forests are great for interpretation and the fast inference, especially under the noise condition. CNN outperform the other in accuracy because they learn the pattern directly from the data, but they require more computational power. So we validate the performance using the multiple metrics like accuracy, F1 score, and AUC. The decisions support layer. After classification, we pass the result through the decision support system. Here we apply the soft voting across all the classifier and include the rule-based logic for the ambiguous result. If the prediction confidence is low, the system can flag it for manual review. So this mimic clinical decision and making increasingly reliable. This is the system architecture diagram. So this diagram gives the complete picture of our framework. Starting from ECG signal acquisition, the data flows through the pre-processing, segmentation, multiple domain, feature extraction, classification, and finally the decision support. So each block is independent and the modular, so making the system easy to maintain and scale. Next, the result and performance matrix. So this table shows the comparative result. CNN performed the base across all the matrix, followed by the random forest. So significant performance dip SVM reflect the limitation in handling the noise and complex features. Overall, this result confirm the strength and multi-domain fusion and adaptive techniques. Next, ROC and confusion matrix. Here we have see all the classifier separated different arithmetic types. CNN clearly show the basic ROE curve, and the confusion matrix also help us to understand the misconfiguration. For example, some normal bits are confused with the AFA due to the similar waveform. So this insight help us to improve our model future. Next, so our finding shows that the combining the feature domain improve the accuracy and reliability, while CNN is powerful random forest in a more resource efficient and the explainable. The use of adaptive patient specific logic is what make the model standard out the real world use. So conclusion, to summarize, our model successfully integrate the diverse ECG feature with the adaptive learning techniques to provide the accurate and real-time arrhythmia detection. It holds the great promise for development in wearable healthcare and remote patient monitoring. So these are the references. Thank you.
Yes, Gauri madam, for nice presentation. I just wanted to ask you that there were three, algorithms which you have chosen, right?
Yes, yes.
Can you go to the slide number around 10 or something?
Which slide?
Yeah, this slide, where the results were shown. Slide number 12. Yeah. Slide number 12. Yeah, yeah. So I can see support vector machine, random forest, and CNN is there.
Yes.
So instead of running all these models separately, just a suggestion that you can run this in ensemble method. So why you have not done that?
Sorry, sir, sorry, ma'am. I'm not able to hear you properly. Actually, your voice is low.
Okay, am I audible now?
Yes, yes, yes.
So there are three models: support vector machine, random forest, and convolutional neural network. So instead of running or instead of executing these models separately, why
Yes.
don't you run these models in ensemble mode, ensemble method? Are you aware of that, sorry, madam?
Yes, ma'am. Actually, now we are working on that. We are actually combining this result. We have taken this result and we are trying to develop the new algorithm, which will again improve the accuracy. We are working on that. Again, we are we are taking the more features for multi-domain analysis. Plus, we are taking the real-time data. Here, we have just taken the MIT BHI data sets. So, we are working on that. We are taking this model, plus we are adding the additional model and we are combining that in one.
Okay.
Thank you, ma'am, for your
Okay. Yes.
presentation.
Yes. Thank you.
Now we will proceed to the next presenter. So the next presenter is Anne Mary Francis from Amrita Vishwa Vidyapeetham. And the paper title is Assessing the Factors Influencing Customer Comfort and Identifying the Areas for Improvement. Ma'am, you can start with your presentation.
Yeah. So good afternoon, everyone. I'm Anne-Marie Francis, presenting our study titled Assessing the Factors Influencing Customer Comfort and Identifying Areas for Improvement in Private Logistics Courier Services. So this research was conducted in collaboration with my colleagues at the Amrita School of Business, Kochi. So moving on to the next slide, that is, we will be discussing the abstract. So this study evaluates how satisfied customers are with private logistics services, especially couriers. So we used surveys and audits to uncover dissatisfaction points. Over 40% of users were unhappy. And the core issues were delivery delays, poor communication, and subpar service interactions. So our goal is to guide improvements in tracking, delivery reliability, and operational efficiency. Moving on to the research questions. So before designing our study, we wanted to identify exactly what aspects of courier service delivery matter most to customers. That led us to develop two main research questions. So the first question asks, which service quality dimensions have the greatest impact on customer satisfaction? So we looked at both soft service factors like staff responsiveness and empathy, and operational factors like tracking systems and delivery speed. So our aim was to identify points of satisfaction, those things that make customers either return or leave. And the second question was, what is the level of influence of each quality dimension on customer satisfaction? So this is where we use regression analysis to determine which aspects have a statistically significant effect and how strong that effect is. So knowing this helps logistics companies prioritize improvements based on data-backed evidence, not just assumptions. Now, moving on to the literature gap. So to position our study, we first reviewed the existing literature on logistics service quality. So most studies focused on large-scale third-party logistics and global e-commerce supply chains, especially in developed economies. However, we noticed a clear gap when it comes to private courier services in India. So these companies often operate in fragmented markets, face logistic inconsistencies, and lack advanced infrastructure. Yet they are essential for domestic deliveries, especially with the boom in e-commerce. So while global models like a cervical are often applied, they rarely consider localized operational constraints like irregular last mile delivery, poor tracking, and staff inconsistency, which are critical in India. So our study addresses this by applying both the cervical
Sorry
model.
to interrupt you, and maybe can we move on to the actual proposed work instead of spending much time on the literature? Yeah.
Sorry, ma'am, I didn't get you.
Okay, can you shift a little bit forward to the proposed methodology?
Okay. So moving on to the theoretical framework, shall I discuss with this?
Go ahead, please. Next. Are these hypotheses proposed by you? No, I think methodology is proposed by you, right?
Yes.
Go to the architecture of this methodology, please.
Okay. So we adopted a quantitative approach to systematically assess which service and operational dimensions most impact customer satisfaction. So we gathered responses from 75 participants who had recently used private courier services in India. So this included both individual customers and small business owners to capture different usage patterns and expectations. So to measure perceptions, we use the cervical instrument, which covers the 5 key service quality dimensions that are responsiveness, reliability, assurance, empathy, and tangibles. For operational insights, we conducted a walkthrough audit evaluating order and tracking systems, delivery speed, information provision, facility infrastructure. So moving on to the cervical results. So this slide shows the results of our first regression model, which analyzed the 5 cervical service quality dimensions and their impact on customer satisfaction. So as shown in the table, most variables had positive beta coefficients, which means they had positive association with customer satisfaction. So surprisingly, responsiveness had a slightly a negative coefficient and was statistically insignificant. So this suggests that speed alone wasn't a key driver of satisfaction for the sample. So reliability and assurance both showed positive trends, but their p-values were above 0.05, meaning the effect wasn't statistically strong enough to be conclusive. Then tangibles also had a positive but weak influence, indicating customers are not overly swayed by appearance or physical presentation alone. Coming to empathy, so empathy stood out as the only statistically significant factor with a p-value of 0.033. A 1 unit increase in perceived empathy leads to a 0.332 unit increase in customer satisfaction. This means customer value personal attention, care, and emotional connection more than speed or appearance. So this results tell us that human-centered service like how well staff listen and care is crucial. Moving on to the next slide, that is the operational dimension and analysis. So while cervical assess service perception, this second regression model used a walkthrough audit data to evaluate how actual logistics operations influence customer satisfaction. So the strongest result came from order and tracking with a beta coefficient of 0.524 and a p-value less than 0.001. So this means that improving order accuracy, shipment visibility, and real-time tracking systems has a very large and statistically significant impact on satisfaction. So delivery speed had a positive effect with a p-value just above the 0.05 threshold. So this indicates it's moderately important. Information dissemination had a small and insignificant effect. So customers seemed less concerned about how much information they received compared to whether the service worked as expected. And facility infrastructure, facility layout, and support systems also showed a positive trend. And though it was in statistically significant at the 5% level, it was approaching relevance at the 10% level. Now, So the moving on to the chart that is regarding the courier service providers used. So as shown in the charts, there's a clear spread across multiple providers. For example, Blue Dot and DTDC are among the most commonly used. India Post still has strong usage in many regions. Delivery and FedEx are also emerging choices, and a significant percentage of users, other users indicate a highly fragmented logistics market. So this shows that no single company dominates the market, and it also explains why service quality and consistency become key competitive differentiators. So moving on to the challenges in private courier services. So working through the chart, as the chart shows, the most common issue is clearly delayed deliveries, which affected a large portion of respondents, which is followed by inaccurate tracking, unresponsive customer support, damaged goods, poor communication. So these issues point to a clear gap between customer expectation and actual service performance, especially in areas like timelines, visibility, and problem resolution. So areas to improve in courier service. So after understanding what issues customers face, we
Ma'am,
ask
sorry for the interruption, but we are past the presentation time. Can we please get to the conclusion?
okay. So as a conclusion, to conclude, our study revealed that customer satisfaction in private courier service is shaped by both the emotional engagement and operational efficiency. So from the cervical model, empathy was the only significant factor. So the key practical takeaways are companies must strike a balance, care for customer and deliver reliably and transparently. Future research opportunities are there are room for deeper exploration, future work, how do these factors interact with each other, etc. Thank you.
Yes. Thanks, Mary, for and best wishes for your future research work. Good work.
Thank you. Thank you. Thank you.
Thank you, ma'am, for your presentation. Now we'll proceed to the next presenter. So the next participant is Fahar Imran from Galgotias University, India, and the paper title is Enhancing Web Page Prediction Accuracy.
Hi, good afternoon, all the attendees and professors. Am I audible?
Yes,
Yes,
you
you
are
are.
audible.
Okay. We are talking about here enhancing web-based prediction. Why three algorithms we have used in this model. Our work address a critical challenge in web navigation by reducing latency and improving user experience by accurately predicting the
Have you
next web
shared
page.
your presentation, Karanjit?
Sorry, sorry for uh, predicting the next
Okay.
web page.
Yes, it is
A
visible
user
now.
will
And please focus on point number three, moreover, 3 and 4, please.
uh, Okay, if we first let us talk about the related work already researchers have done in this uh, area. Researchers have used the Markov models basically for predicting the next web page or hyperlinks transition, but they are less efficient because they only use the present data. If we use higher models, there is a lot of complexity in those models. What we have proposed basically, we have just use three algorithm, logistic regression and naive and Markov models, and then we assembled all three models to get best of all of it, all of from all of three basically. For logistic regression, we have used to get the relationship between linear variables, probabilistic regression. Naive we have used for this just having independence between all the variables, like we have used session time, all kind of variables. Markov models to get the previous or little bit more predictive accuracy. background research. Already our researcher have done of that in our model for get best of coefficient from all the output. If we talk about performance and result, we have used binds that gives our independently logistic regression gives about 87. After ensembling, we are getting about 90%. The data set actually we have used not as a public data set. We have used data set from our college, and also we will try to in future to make it get a bigger data set also. Thank you.
Okay, what is the size of data set?
Actually, it's about 5,000 students in our college from all medium, all classes, all streams.
Okay, is that
Uh,
data set publicly available?
no, ma'am. We have just done a survey through our Google Forms. That's why we get.
Okay,
um,
okay.
Okay.
Okay, thanks, Karanji.
Thank you.
Thank you, sir, for the presentation. Now we'll proceed to the next presenter. So the next presenter is Manoj Ramashish Gupta from Shah and Anchor Kuchi University Engineering College. And the paper title is File Storage and Sharing Using Hybrid Cryptography.
Am I audible?
Yes, sir, you're audible. You can start with your presentation.
Okay. Okay, so my paper is based on the project we have done it through. We have done in our final year of engineering. So in which I have made a project named as file storage and sharing using hybrid cryptography. As we said, like uh, due to security measures, we have encrypted hybrid cryptography, which can be used to share file, which can be used to encrypt the data. So, as digital data grow rapidly, secure and efficient storage is becoming more critical as people have critical data which need to be stored. So, we have implemented hybrid cryptography, which involves symmetric and asymmetric cryptography. Symmetric cryptography means using a single key, like public and private key will be the same. But in asymmetric key, there we will use two keys, as we have mentioned down. So, in symmetric key, a single secret key is used to encrypt key encrypts and decrypts data, as I've said. And asymmetric key it uses as public and private key, a sender key and a receiver key. So this is the methodology I have used. So first, like when a file data set has been inserted, it get divided into equal chunks, like as a equal bytes, and the secret key has been generated. So this is the encryption used. We have used 3 to 4 encryption. The first one is AES. AES is Advanced Encryption System. So here a sender, like if I am the sender, I have I have uploaded a file. It will goes to an encryption server, which is basically the algorithm we have used. It will generate a secret key, and the same secret key will be given to the receiver, so that only the secret key is exchanged in this, and the file has been shared through secret channel. And this is the research we have done through this project, where we have studied many different paper available. This is the new algorithm we have found. It is the latest one. It's named as CHA. It uses a 512-bit state, 16 words and each 32 bits, which is a new in the market, as there is new that as there were very few algorithm which uses 512 bits. This is the basic description of that, which is the 4 constant word, 8 keyword, and 4 nonce. Combination of counter and nonce for unique encryption group. Because if the bits has been expanded, there has been there are separate counters which we used. So nonce is number used once. In CHA, the number is only used once. This is the encryption algorithm we have used. with the memory space key generation speed, so that it gives a comparison analysis of how the key has been used. So these are the like ECH, DHE, and AES. We have combined that, which uses low memory space, and it generates a 120 bit and 256 key, same as AES 256, which is a which uses high functions, which key generation is fast, to generates 256 bit, and the efficiency is high. Same for RSA 2048, which is a 2 KB name. High, slow, 248, and low. Well, this is the last one which we are studying currently now, and this is the latest one we have found. This is these descriptions. Whilst this is the till now we have completely secured the file. Now to enhance more security, we have upgraded the projects on cloud architecture. As you can see, that is AWS EC2. This is the cloud architecture we have done. So like we have created account, we have created server, so that the file which is been stored on server, it can be which can be safely secured on cloud, so that even if the file is required laterly, we can use it. Now you can download from the cloud. These are the screenshots of the, like here we can see the PEM file. PEM file is basically used to secure private key and public key. So this is the screenshot of that, and this is the advantage and application out of like it is an efficiency security. It has security because we use different types of hybrid cryptography. As it is scalability, because the current projects can hold up to a GB file. Like the file can be uploaded at a GB. Like it is a limit till of 1 GB file. Thank you.
Yes, thank you, Manoj. Siddhi, yeah, we can go ahead. Yes, thank you, Manoj, and best wishes for future research.
Thank you, man.
Okay, ma'am, we will go on to the next presenter. So the next presentation will be given by Dhruva R. Rinku from CVR College of Engineering. And the paper title is Flood Rescue, an Integrated GIS and Remote Sensing Based Decision Support System for Flood Inundation Warning and Relief.
Good
Ma'am, if you're
afternoon.
there in the meeting.
Yeah,
Okay,
I'll
you can.
share. Yes. Is it visible?
Yes, ma'am.
Okay. So I'll close my video because here signal issue is there. I am from college. I'm presenting it.
Sure, ma'am. There is no issue.
Okay, ma'am. Yeah. So good afternoon, ma'am. Good afternoon, participants. I'm Dr. Dhruva from CVR College, and the topic of this presentation is flood risk, an integrated GIS and remote sensing based decision support system for flood, inundation, warning, and relief. And ID is 96. So as we know that in India, basically ours is a developing country, and in floods wreak havoc that can take decades to recover from. To effectively mitigate the impact of flood disasters, precise flood inundance warning are essential. This system employs a geographic information system model constructed using a DEM, that is digital elevation model, and building shape files to analyze land behavior during floods and identify inundation risk in various locations. This information is crucial for taking proactive measures to reduce flood-related destruction promptly. So we are using GPM, that is global precipitation measurements. Half hourly rain data is utilized here to assess it to rainfall on flood conditions across different regions. And we have generated website for the flood relief system with the use of PHP and MySQL database. And we have used the Arduino and of course GSM module for the sending the message to the people who wants to send relief, say even food or say money to the flood affected people. So the introduction part already I have told. Then due to flood in India, especially in the Mumbai area, many damages happening. Even loss of lives, loss of drinking waters, and of course, due to that, farms are also getting affected. So this particular model has designed with the GIS input, and this is the survey of the flood occurred mainly, which has given lot of loss in our country. So here, this is to find basically two areas which is prone to flood. And we are using, and finally we are sending message with this website, as I told before. The study area we have taken is Mumbai. So normally Mumbai is getting and which is highly populated place. And what is happening is Mumbai may in Mumbai, precipitation is almost 242.2 centimeter in average. So we have taken this, and maybe and even it is surrounded by the sea. So even Mumbai flood also we have kept it in the survey. So in this system, GIS model we are using for to finding the buildings and the nearby area where the area can be affected by the flood. So we have used the GPM data from the taking from the government site, mainly from the Bhuvan.
Madam, can you move to the proposed methodology, please?
I didn't get, ma'am. Hello, ma'am.
Yeah. Yes, please. I was saying that you please shift to the proposed system.
Proposed, okay, ma'am. Okay, ma'am. So here we have used the, of course, GIS, and which is giving the 3D image of the area, and we have used the ArcGIS model, and with the use of ArcPI, this is Python package, and to get the data and work on the data of the images. So we have taken the SRTM from the radar, that is digital elevation model input. And then we have find out the blue spots by the running the code in the ArcPy. And blue spot is the area where due to the due to the water fill up, and when it get combined, this type of filling area, it can create the it may create the flood. So this is the program for that. And we have generated this output by the use of RPI. This is the program. So this is the field, the one tool we have used on the map, that is GIS input, that is field tool. So in the field tool, it will find out that which area can generate the blue spot, and nearby blue spot area has been taken as a data input and given the output by the tool, that is field all things output. This is the output from the tool, and we have used the minus tool in the ArcPy area, which will be perform the subtraction operation on the rasters, and it will, after minus tool, the output of the map will be the red area is the flood. It can generate the flood prone area. And then we have used the condition tool. In the condition tool, the lookup table data will be generated, and this true or false. We have taken the output of condition tool is this. And then we have used the region group tool. So in the region group tool, we got output this in the our IDE. And from the DSOL tool, we have generated that output for the building. And these are the building which can affect by the flood. So in the raster to polygon tool, which will be generate the polygon output, and it is now creating the building output, which can be generated, which can be affected by the floods. So these are the tools we have used it. And then from the GPS data, again, we need to convert to the area, so that
Ma'am, Ma'am,
Yes.
sorry for the interruption, but we are past the presentation time. Can you please get to the conclusion?
Sure, sure. And then we have used the raster calculator. Give me 1 minute only. So with this raster calculator, we got the output of the watershed, and now these pink areas are the buildings which are affected by the flood, and we have used the global precipitation mission input. So this is the output for that, the generated, how this calculation will be done in stepwise. And then we need the reverse geocoding, because we need the area. This will give the latitude and longitude output. So then after that, we have to calculate the straight city, state or country which is getting affected. So we have used the reverse geocoding. And then we have generated the relay system, and there we have generated the website with the MySQL. And this is our web page. There people can log in and they can get that affected area. They can send the food, or this is the photos we have taken from the website which we have generated. And then we have used the Arduino simple processor we have used to, and GSM module to generate this particular website to run and to send the SMS to the registered people. Thank you, ma'am. Thank you. Ma'am?
Thank you, ma'am, for your presentation. Are there any questions?
Yes. So how many papers you have surveyed for this research work?
Yeah, ma'am. We have almost 9 papers, reference papers, and we have seen even a different way of finding the flood in that. Even ultrasound technique is also, we have checked it. But what is the problem with that technique is the flow of flood, it is not showing. And due to the different sound, it is not getting exact output of the floods. So that's why we felt this is the better technique, ma'am.
Okay. Okay, fine. Yes, thank you, madam.
Thank you. Thank you.
Yes, please, Siddhi. Go ahead.
Yes, ma'am, sure. So the next presenter is Nikita Patil from KLE Technological University, India. And the paper title is Lane Departure Warning and Correction System with Control Logic on FPGA. Nikita ma'am, you can start with your presentation.
Yes,
I
ma'am.
think,
I'm just
Siddhi,
sharing
after
my
some 7 minutes, can you remind? Siddhi, am I audible?
screen. Hello.
Yes, Nikita, please proceed.
Got interrupted. Can you please say it again?
Hello. Yeah. Is the screen
Yeah.
visible?
Siddhi, I was saying that can you please remind after some 7 minutes that
Hello.
they need to wind up?
Yes, ma'am,
Is the
sure,
screen
sure.
visible?
Please.
Yes, I'll be raising a
Hello.
reminder, and this is a kind request to all the participants to try to wrap up your presentation within 7 minutes so that we get enough time for the question answers and other participants as well. Nikita ma'am, you can start with your presentation now.
Hello.
Hello. Hello, ma'am. You can share
Yeah.
your
Am I
screen now.
audible, ma'am? Am I
Yes, yes,
audible?
yes. Ma'am, please share your screen.
Hello.
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 Yes, ma'am, you are
Yeah.
audible.
I've
You
shared
can
the
start.
screen. Yeah. I
Okay.
have shared the screen, ma'am. Is the
Ma'am, we are
screen
not.
visible?
No, it's not visible yet. Please try to share it
Okay.
again.
Yeah. Yeah. Sure. Sure. Am I audible? Is the screen visible to you all, ma'am?
No, ma'am, we cannot see your screen. If you are facing some issue with the presentation, What we can do is we can have your presentation later on. We'll continue with other participants right now. Is that all right? Until then, you'll get enough time to fix the PPT issue. Okay.
Share my screen, ma'am.
Ma'am, I cannot see your screen. Ma'am, in the meanwhile, we will just continue with another presentation. You can share your, you can share your
Okay,
PPT
ma'am,
link.
sure. Okay, 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 okay.
So the next presenter is Gauri Gautam from Merit Institute of Engineering and Technology. Ma'am, if you are present in the meeting, please start with your presentation. I think she's not there in the meeting. Meanwhile, we'll just move on to the next presenter, which is Jamin Dave from Silver Oak University, India. And the paper title is Maximizing Detection Coverage in Ideas Through Hybrid Deep Learning Architects. Sir, please start with your presentation.
Siri, can you hear me?
Yes, sir.
Okay. Okay, I'm just presenting my screen. Visible? All good?
Yes, ma'am. Yes, sir.
Okay, so very good afternoon, everyone, Professor and the esteemed moderator. My topic is maximizing detections coverage in the IDS through the machine learning. I'm thankful to my guide Chintan sir and the Primal sir for their constant support. So
Sir, can you please maximize the screen?
I did it, ma'am.
It is not reflected on our screens. Just refresh once, so we will be able to see the PPT.
Okay, I will just stop it and I will restart it.
Okay, that's fine. Now we are able to see it. Sir, you can continue with your presentation.
Okay, so this will be the outline of my presentation, but okay, I heard ma'am what said. So I will be just saying few stuff about the background. Ma'am, my research work was started in 2020. So by keeping the cyber landscape in mind, the kind of a phishing attack and different kind of a attack which I have seen, and that's how I have opted for this kind of a problem definition, which was a network-based intrusion detection system. So mainly here there are many kind of IDS, but I will be focusing on the network based IDS, and it is a key parameter to monitor and the protect any computer network system. The problem statement: over the research work precisely during 2020 to 2022, what I have come across, people have worked on the machine learning models. uh, there was a limited work on the hybrid based model, so lack of the hybrid approach was missing, and the various kind of a pre-processing technique which I have tried to explore with the trial and experiment trial and experiment pattern. That's what I will be talking in my proposed model as well. Ma'am, various research work literature review has been carried out here. Somebody has taken a control. Siddhi?
Sir, we were able to see your screen and I have not shared anything yet. So I don't think there should be an issue. Just do it, try to do it again.
Nah, probably Nikita ma'am just came in and my presentation went away.
Okay, sir, now we cannot see any presentation. You just continue with your presentation. Just share the screen again.
Okay. Okay, a literature review slide. Can you see that?
Yes, yes, sir.
Okay.
Please continue.
So the third paper, like that was considered as one of my base paper where I have applied the hybrid model for the higher accuracy and for the reduce the false positive purpose. So again, a list of a literature review. My main aim is to combine a CNN LSTM and to give a better accuracy. So these are the four parameters that was kept in my mind before starting this work: accuracy, precision, recall, and the F1 score. So again, just talking about the objective, I have compared with my work with the basic machine learning model that may be SVM, random forest, standalone CNN, standalone LSTM, and as well as I have compared with the CNN LSTM model. The impact of the data pre-processing and the main thing is integration during the data pre-processing phase. I said it clearly. My work is limited for the network-based intrusion detections. The performance of the CNN LSTM model was evaluated using the predefined data sets. I have worked on the KDD, IC, IDS. They had a more number of attributes and the data sets which I'm gonna use, and I'm gonna also tell you. So this is the data set which I have used. That's from the Lancaster University. So ma'am, the left hand side column which state that from 2020 onwards, they have start publishing those data. I have relied my final work of implementation was carried out based on the data which was produced in 2022. So again, more than 26 million of a rows. It was a huge data set. So many challenges I had come across. So, okay, coming to the number of a column. So again, starting from the source IP to the label, there are 16 attributes were there in my data sets. And again, it's just a top view glance of my data sets. How does it look like? So I just try to put in a one frame. Okay, now probably everybody will be interested in this proposed model, and that's where the cleaning, dropping, and handling the missing value. So we just say that like this is the pre-processing, but okay, wherever it was required to impute something, I have imputed by making a use of the mean, mode, or median calculation. And wherever it was found it was irrelevant, at that time I have also dropped a few items, then removing the duplicates and the inconsistent format. Somehow it was triggered using one Cisco Citrus tool. So somewhere the data were not consistent, so I have also tried to work in that direction. So again, currently I'm talking about my pre-processing phase. So cleaning, dropping duplicate, this is what I am saying just in a word, but okay, a lot of work was carried out for the same. Now here I have mentioned the three models. On top of that, I have also trained for the random forest as well as the SVM. When I talk about my trained data and the test data, my 80% data was categorized under the train model and
Yeah,
remaining
hi, Jamin.
sorry.
Can you shift to the results part, please?
Sure, ma'am. Okay, so just a few line of implementation code, ma'am.
That is okay. Implementation is clear.
Okay, ma'am. So, okay, ma'am, this is my result and discussion. Again, like, ma'am, I have improved this work like anything, but okay, for this research paper, the initial, my finding was when I was combining my CNN LSTM, this was the result I have received when I combined the CNN and LSTM together. So that's the same thing I have plotted in the bar chart. And again, CNN LSTM give me a better result compared to the standalone model. and mainly the pre-processing area I have drastically improved. If you allow, then in future work, ma'am, what currently I am doing it, I have also incorporated auto encoder and the k-mean cluster in the pre-processing part. So again, after just receiving comments and the review from my guide, I have optimized that pre-processing part. And now, instead of just comparing with the standalone model, I am working with the XGBoost and the Light BGM. When we talk about the ensemble model, I am carrying out my further work in this direction, ma'am. So again, ma'am, over to you.
Yes, thank you. Thank you, Jamin.
Thank you, ma'am.
Yes, Siddhi.
Thank you, ma'am.
Hello.
Now proceed.
Hello.
Yes, ma'am.
Hello. Yeah. This is Nikita.
Okay, okay. Ma'am, do you want to share your screen now?
Yes, ma'am.
Ma'am, just try sharing quickly. If it is
Yes.
there, okay, if there is an issue, you can just send it to me, then even I can share on your behalf.
Yes, ma'am. Sure.
But for now, you just try to share.
Okay. 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 Your browser is preventing. Ma'am, please, can you just share me your mail ID? I'll share my presentation to you itself.
Okay, ma'am, I will share my mail to you in the chat box.
Okay.
Meanwhile,
Sure.
we will just have another presentation. We will just reschedule yours, okay?
Shruti, she can also like share that PPT in this chat box also.
Yes, ma'am, you can even share it in the chat box as well. So you just have to go on to that
Okay.
share document section.
Chat. Okay.
Okay, so meantime, we can go on to the next one.
Yes, yes, sure, ma'am. We will not waste any time. We can go on to the next presenter and then we can have our presentation. So the next presenter is Safa Imtihaz Sayed from KLE Technological University. And the paper title is Ordinate Object Detection in Dark with Attention-Driven RGB Event Fusion. Ma'am, you're there in the meeting. Please start with your presentation.
Yeah, is my voice audible?
Yes, ma'am.
Okay, I will share the presentation. Is my presentation visible?
Yes, ma'am.
Okay. Okay. So good
Ma'am, just
afternoon to
reduce
all.
the font a bit because it is quite zoomed in.
I did not get you.
Ma'am, the font is very big actually. You have zoomed in the PPT. So when you're sharing, we are only able to see a small part of the presentation. So just normally share it. Just okay. Yes.
Is it correct now?
No, actually, ma'am, it is again giving the same issue.
Okay, I'll.
Okay, now it's better. Okay.
Okay. Okay.
Yes,
Okay.
it's
So good
all
afternoon.
right now. Just start. Okay.
So actually, I begin.
Yes, ma'am. Yes, ma'am.
Okay, so good afternoon to all distinguished attendees. I am Safa Imtiaz Sayed, and I'm honored to have this opportunity to share my work on object detection in low light conditions using RGB event fusion. The title of my presentation is ODNET, that is Object Detection in Dark with Attention Driven RGB Event Fusion, conducted as part of my research at KLE Technological University. So, this is the quick overview of the presentation. I will follow the next slide. So we know that object detection is a key task in areas like autonomous navigation, surveillance, and robotics. But traditional RGB models, they suffer significantly in low light environments due to noise, motion blur, glare, and low contrast. Event cameras, on the other hand, they are minimal latency, high temporal resolution, high dynamic range camera sensors, which are pixel level intensity monitoring camera sensors, capturing the change in brightness of the objects. But they lack texture and spatial details, and they perform well in high dynamic scenarios. So our problem statement, therefore, is to develop a robust RGB event fusion model to enhance object detection in low light autonomous low light autonomous driving by leveraging the complementary strengths of both the RGB as well as event modalities. Coming to why we took up this research challenge, is the main question is, why is object detection in dark challenging? So we know that low light object detection is fundamentally challenging because of poor visibility and insufficient contrast. And we also know that RGB images and event data on their own, they are not sufficient, because RGB images, they provide high spatial and color details, but they lack uh, practical usability in dark scenarios. Whereas event data, they excel in capturing motion and brightness changes, but they cannot provide a complete contextual picture. So therefore, we need a fusion strategy which combines the spatial strength and color details of RGB image and the event temporal resolution and dynamic range. So coming to the objectives, first is to design a low light enhancement pipeline using 0 DCE to improve the RGB image and integrate the event data with a cross fusion attention strategy. Second is to build a tailored loss function which balances exposure, illumination, perceptual quality, and detection precision. And the third one is to evaluate the effectiveness of our model using the frame MAP and video MAP, and also an ablation study on the same. The literature survey is again several studies which are based on event cameras and RGB fusion separately, and the initial work on the fusion strategies. Our approach draws inspiration from these, but builds them on integrating the spatial and temporal data in a unified architecture for low light detection. So the proposed framework, this is the architecture of OrdNet. We have the data input stage where the input of RGB image and its corresponding event frame is fed into the respective data preprocessing models. First, the RGB image is enhanced using 0 DCE to correct low light distortions. Parallelly, the event image goes through a multi-scale aggregation network to extract certain temporal features at various resolutions like R1, R2, R3, and they are concatenated. So this is done, after which the features are extracted using the respective feature extraction modules, that is a ResNet 101 for RGB enhanced RGB image, and ResNet 18 for the improved event data captured concatenated via the ETMA module. Later on, we have the cross fusion network, where these features are combined in a cross modality attention based fusion block, which captures the complementary patterns from both these inputs, which then we go to the detection decoder, where the fused features are passed through detection decoder, and then the output is compared against the ground truth labels to compute the loss. Our loss functions are basically perceptual loss, detection loss, and the 0 DCE losses, which are the luminance loss, chrominance loss, gradient preservation, and total variation smoothness loss. So this is again the detailed structure of the proposed framework, where we have the 0 DCE for low light enhancement for enhancing the low light RGB images, and the temporal multiscale aggregation to process the event data, which are then fed into the respective feature extraction modules. And then we have the attention driven cross fusion for the RGB and event features to fuse them. And then we have a total fused feature map, which is fed to the detection decoder, and the loss functions are then calculated. So this slide shows the visual comparisons of different modules. We compare a traditional RGB only module, a baseline fusion module called RDNet, and our proposed OrdNet. We can observe that our model preserves more structural detail and successfully detects objects in the low light regions, whereas other models sort of fail. The enhancement using 0 DCE plays a vital role in preserving the luminance, whereas the fusion model improves localization. This is the qualitative result. Followed by the quantitative result, here we present the model's quantitative performance based on the frame mean average precision and video mean average precision at an IOU threshold of 0.5. We achieved a frame MAP of 45.8% during the daytime and 28.3% during the nighttime, which demonstrate a notable improvement over the RGB only and the initial baseline event RGB fusion model, RENet. And next, we have the ablation study, which is done to evaluate how each component of our model, OrdNet, contributes to the performance. We systematically removed certain parts of the model, such as, for example, zero DC module or the attention fusion block module, which gives us the explanation of how each module on its own is responsible for the complete OrdNet. So the resulting drop in performance in both the frame MMP and video MMP, if we remove any particular loss or in particular module, validates the importance of each module. And this also confirms that our fusion strategy and enhancement pipeline are essential in achieving robustness in low light scenarios. In conclusion, OrdNet provides a novel and effective solution for object detection in dark environments by fusing the enhanced RGB images, which are rich in color and spatial importance, and by event data, which is rich temporally. We infuse them using attention-driven fusion. Our model achieves superior performance in terms of accuracy and detection generalization.
No time. Bahir sir.
In future work, we plan to introduce specialized loss function for motion
Okay.
and
Yeah,
semantic
Safa.
awareness. Okay.
Am I audible?
Yeah, we are done. And these are the keywords. And thank you for all attention. And I'm happy to take any questions if you have.
Okay. So there is a little difference between day performance and night. You can see on the last slide which you have mentioned on slide number 14. So what is the reason behind that? Like for day it is 45.8, whereas for night it is 28.3. So why
Okay,
there
so
is such a
basically,
difference?
yeah, because in daytime we have the better contrast in color, and also the fusion model performs much better. Like we have current models for daytime, and they all have an FMAP, a mean average precision of 45 of in that range. So our model achieves the state of art in daytime. For nighttime, many of the work is being performed, and there are few works. Sorry, for daytime there are many works, but for nighttime there are fewer works. So we had compared it to our baseline model, and we achieved a better FMAP of 28.3. This could be because of how the detection model acts in the night versus the day.
Okay, thank you.
Okay, thank you so much.
Yes, Siddhi.
Now we will go on to the next presenter. Nikita ma'am, I have your PPT with me. So if you don't mind, then I'll
Yes, ma'am.
share it on your
Hello.
behalf. You just tell me when to change slides. Then we can have your
Okay.
presentation. So
Okay.
just let me know if your PPT is
Uh,
visible.
yeah, Siddhi, is
Yes,
this
ma'am.
the last one?
Can you see it?
Is this last one?
Yes, ma'am. It's visible. Oh,
Okay. Now you can just start with your presentation and let me know when you want to change the slides.
yes. So, hello.
Hello?
Yeah, am I audible? Yes, ma'am.
Yes, ma'am.
Okay. So my paper ID is 149, and the work what I'm going to present over here is it's a lean departure warning and correction. Author, my name is Nikita Patil, Dr. Basavraj. We are going to present our work over here. So let me, next slide, ma'am. May I have a next slide, ma'am?
Yes, ma'am. Just give me a second. Okay. Can you see the next slide now?
Yes. Okay.
Okay.
So we all know that almost the modern ADAS systems, which are meant to improve the vehicle safety by lowering the accidents, have been bought and advertent by lane drifting, must have a lane departure warning as well as the correction system. So that is why we consider them as the essential components of the modern ADAS, which have been aimed at improving the vehicle safety. And almost these systems try to detect the unintended lane departures, and they alert the driver or apply the corrective actions to steer the vehicle back to its lane. As we all know that there are certain advanced image processing methods like the Hawk transform, CAN edge detection, which precisely try to detect the lane borders in the real time and frequently used in the development of our such systems. And we also know that the traditional implementations can also be done by the usage of CPUs as well as GPUs. But at that time, we may suffer from the high latency and increased power consumption, which is not proved to be the ideal for the embedded automotive applications. So that is why we stress over here on the FPGAs, which try to offer the parallelism, the low latency execution, then the hardware level time determinism, as well as they prove to be a reconfigurable processing systems, which makes us suitable to work over the real-time systems. And when we try to go for the FPGA-based control logic, they ensure fast decision making as well as real-time response and the reliability over under varying the road as well as the environmental conditions. Now, next, let's go. What is that which motivated us to go for designing this system? Ma'am, can I have a next slide?
Yes, ma'am.
Yeah. So the motivation behind this is we also know that due to this lane departure accidents make up a large percentage of the traffic accidents, the making the road safety as a major worldwide concern. So these accidents which cause unintentional lane changes are frequently caused by the driver distractions, exhaustion, or some poor vision problems. So due to this, and there might be the limitations of the traditional processor-based systems, and we have the advantages for FPGA for the real-time safety systems, then bridging the gap between the vision as well as the control, then the
Hi,
interface
Nikita.
due
Am I
to this
audible?
motivation having behind it is to improve the road safety in order to create a mechanism to stop the accidents which were brought on by the inadvertent lane changes, which will lower the number of traffic accidents as well as encourage the autonomous part for the ADAS, which can offer in the development of the autonomous as well as the semi-autonomous vehicles. Ma'am, next slide. Hello.
Ma'am, I've
Hello.
moved on.
Hello.
Hello. Yes, ma'am. Hello. Hello. Ma'am, please continue with your presentation.
Yes. Can you shift to the proposed methodology part, please?
Okay.
Yes. Next slide. Fine.
Okay. Please continue with your presentation.
Yes. Please go ahead.
Is there any issue?
Hello. Hello.
Yes, ma'am. Ma'am, please continue
Yes,
with your
I was,
presentation.
yeah. I was not able to hear you all. So the finally we have yes. The design methodology is we have gone through, I mean, we have taken as the input, then we have decoded few video files into the frames, converted them into the grayscale. Then we have tried to reduce the noise by applying some filters. Then we have tried to detect the edges. We have masked them using the edge detection ka principle. Then we have find out the coordinates have been find out on the lanes. Then we try to fit them, find its curvature, and finally the steering rotates. So the results part concentrate on the image of the prototype has been displayed, and as well as we have got the confusion matrix for it, and we have tried to compare
Hello.
the previous processing the
Hello.
hello hello
Ma'am, we are already past the presentation time. Can you please get to the conclusion?
I'm not able to hear you, ma'am.
Yes, it is done from her side, Siddhi.
Yes.
Okay, fine, Siddhi. Can you move on? Is there any more
Hello.
presentation?
Yeah. Am I
Yes, can
hello?
you make it? Oh,
Hello.
Hello, ma'am, you are
yes.
audible. I just want you to get to the conclusion because we are already
Okay.
past the presentation time.
Okay, ma'am. Okay. So finally, I would like to conclude that the FPGA-based lane departure warning and correction system offers an effective and reliable solution for driver assistance and vehicle safety. And it enhances functionality by providing the directional guidance, which helps to in lane departures, as well as this technology ensures high-speed processing, which makes it ideal for the advancement of the ADAS, which improves the road safety. So the future implementations, what we can offer of vision, as well as ensuring compliance with the automotive safety standards. Thank you.
Yes, thank you, Nikita.
Ma'am, we can move on to the next presenter now.
So, I think that was last one, right, Nikita? Am I audible?
Hello.
One
Yes,
more
ma'am.
Yes,
minute.
ma'am.
Okay.
There's just one more presentation left.
All right.
Okay, so this is the last presenter now, Harshal Vijay Chaudhary from Vishwakarma Institute of Technology, India. And the paper title is Personalized AI Doctor. I request Harshal Vijay Chaudhary, sir, to please start with your presentation or any of the other members or co-authors.
Hello, ma'am. I'll share my
Yes.
screen.
Okay, ma'am, sure.
Is my screen visible?
Yes.
So good afternoon, ma'am. Our project was a personalized AI doctor. So, like this project aims to combine the power of artificial intelligence and also the healthcare one to provide the accessible medical advice to the people, especially in the rural areas where the means like in many regions like the rural areas or underdeveloped area, people face many difficulties like timely or they may not get the accurate medical advice at a appropriate times. So that's why was our problem statement. So the idea for our problem statement came for from observing that how the overburdened our healthcare system is and how we can use the technologies to transform it into everyday services. And if the AI can, or we can create a chatbot which can recommend us the advice at a particular appropriate time, especially when it comes to rural area where the at appropriate time the medical care may not be received. At that time it will be a useful one. So this was our objective of our project. Like we have to develop an AI-powered virtual health assistant. We need to integrate the natural language processing and text-to-speech technologies in that, train the machine learning models, implement a scheduling system, build a secure web-based telemedicine platform, and integrate the telemedicine platform. So this was the literature review. These were the certain papers through which we have gone through. Uh, like this was the gap analysis of our project. Like the conceptual understanding, like advanced NLP and deep learning method techniques were used here for better handling of the complex queries. Then also the enabling the prediction using AI, so users can get the instant guidance, then suggesting basic medicine for early symptom relief. Service integration we have also implemented here, like the secure appointment scheduling and telemedicine for seamless access. These are some concepts which make our project stand out from the existing one. This is the system architecture. Like our system is designed with some modular components which work together to simulate the experience of interacting with doctors and users, like from initial consultation to booking a medical appointment. Like at a user's end, the journey will start from the chatbot. Like he will give the input uh, in the form of speech voice, which will be converted into the test uh, text. And when a user will enter its symptoms, it will be the processed by natural language processing engine, which will help the system to understand what the user is currently facing. Then the process input will be sent to the server, and after that it will based on the symptoms which was given by the user, it will predict what the disease it they may have, or means what are the symptom which symptoms are of that particular disease. We have trained it on some like we have put it in that script, like what the symptoms are there for some particular this. So, and if the user wants some further consultation for that, the interface is allowing them to book an appointment with a doctor, like based on the availability of the doctor, and all the contact details are stored in the MongoDB. So yeah, this is the methodology. First, we are collecting the user's details and store them in MongoDB. Then we are collecting the symptoms. We are using a dynamic Q&A session with them. Like we are taking the symptoms which they are facing. On the basis of that, the disease is getting predicted. Then we will be showing them these are the available doctors, and they will select based on that. And accordingly, they will book an appointment, and a meeting link will be generated, and all these details will be again stored in the MongoDB database. So this is the use case diagram for our project. Like these are some, like patient one is there, doctor is there, what the use cases we will be taking, like the age, uh, symptoms and all that. And next one is we have also added the sequence diagram.
Now, Asta, can you shift to the results part, please?
Yeah. This is the text stack we have been used, and this is the report. Like we have generated the what will the patient point of view and the doctor viability one. um, so can I conclude, ma'am?
Yes, please conclude.
Yeah. So like we have so here I'm concluding my PPT. Like we have used your we have integrated the features like voice based interaction, symptom analysis, disease prediction, then online appointment scheduling, meet scheduling, and So with this integrated approach, the project will enhance the efficiency of the medical consultation, and it will also ensure that the healthcare advices is available to individual regardless of their location and mobility constraints. Um, Thank you all for your time, and I'm happy if you have any questions. I'll happy to answer that.
Yeah, thanks, Asta, for the presentation.
Thank you, ma'am, for your presentation. Are there any questions? Okay, if not, then I'll just proceed with the closing remarks. I sincerely thank our authors for their excellent presentations and contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of whole team, thank you for support during the 10th version, all the previous 9 versions of the conference. We will be happy to see you in the 11th version in 2026. All the presenters would be getting their digital certificates via email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 7 to 8 minutes, so kindly cooperate with the team of ICT4SD. And lastly, I also want to thank our session chair, Dr. Anuradha, for chairing this session.
Yes, thank you, Siddhi, and best wishes to all the researchers.
A token of appreciation to the chair on behalf of Team ICT4SD and Global Knowledge Research Foundation and partners. Now, just before we end this session, I would like to request all the participants and ma'am to please turn on your camera so that we can take a quick snapshot of this virtual conference. We'll just wait for like 5 seconds and let everyone turn on their cameras. Okay, I've taken the snapshot. Thank you, everybody. Now we can end this session.
Yes, thanks, Siddhi. Bye. Have a great day.